Today's lesson is angles in polygons. Polygons, remember, are a closed shape of 3 or more straight lines that do not cross. So we've got 3 polygons here, and what we're going to do is divide them up into triangles so that we can find out how many degrees are in each of these polygons. Now, one thing you have to remember that I've told you before, that a triangle, write this down in your notes, has 180 degrees total. Okay? 180 degrees. If you add up all of the angles in a triangle, they have 180 degrees. Okay? So here we have a triangle, and in this triangle, this will add up to 180 degrees. Okay? So if we can take a polygon and divide it up into triangles, then we can figure out how many degrees are in that polygon. So here we've got a square, well, it is a square, but it's also a rectangle. And what I'm going to do is I'm going to divide it into triangles. So I start with one of the vertex. It doesn't matter where you start. And I'm going to draw a diagonal from one vertex to the other. Okay? Now, I can't really go this way because I'm not turning it into a triangle when I do that. So that's not going to work. But if I go from this vertex to this vertex, I have now turned that rectangle into 2 triangles. This triangle has 180 degrees, and this triangle has 180 degrees. And 180 degrees times 2 gives me a total of 360 degrees in this rectangle. All right, so let's start a chart over here. Let's go with a triangle has 180 degrees. A square or rectangle has 360 degrees. Now what do we got here? Let's count the sides. 1, 2, 3, 4, 5. We call that, what do you remember? Starts with the P. This is a pentagon. Okay, so let's divide the pentagon into angles. It doesn't matter what vertex you start from. Now I'm going to start from down here, and I'm going to draw from this vertex. Well, we don't want to do that. There we go. Let's get rid of our little dots. From this vertex to that one. Hey, I just made a triangle. That's 180 degrees. Now I'm going to go from this vertex to that one. That one's 180, and that's 180. I can't make any more triangles, because if I go this way, that doesn't make a triangle. So 180 times 3, get out your handy dandy calculators, and what do you get? 540 degrees. Okay, so a pentagon is 540 degrees. Okay, let's see if we can see something here. A triangle has 3 sides, right? Let's say the number of sides and the number of triangles you can make. Let's see what we can come up with. A triangle has 3 sides, and it makes 1 triangle. A square has 4 sides, and I can make 2 triangles. A pentagon has 5 sides, and I can make how many? 3 triangles. This is getting interesting. What do you think? What's the next one? Hexagon? How many sides does a hexagon have? 6 sides. How many triangles do you think we'll be able to make? Well, if this is going according to plan, looks like I should be able to make how many? 4? Let's see. All right, I've moved my triangle out of the way. So here I have a hexagon. 1, 2, 3, 4, 5, 6 sides. Let's see how many triangles we can make. How about if we start right here in the middle? I'm going to go from here to here. There's one triangle. From this vertex to that vertex, there's 2 triangles. And from this vertex, notice I always start at the same vertex. Well, that was kind of a not a very straight line, but let's try that again. There we go. All right. So how many triangles did I make? 1, 2, 3, 4. And this is 180, and this is 180, and this is 180. So now I take 180 and I times that by, multiply that by 4, and the number of degrees in a hexagon is 720. Let's see. A heptagon has how many sides? What do you think? Oh, 7. How many triangles do you think we'll be able to make? 5. What do you notice between the relationship of this number and this number? Between the sides and the number of triangles you can make? What do you notice? The number of triangles you can make is 2 minus, is the number of sides minus 2. 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3, 6 minus 2 is 4, 7 minus 2 is 5. And if we had an octagon, it would have 8 sides. How many triangles? 6. All right, let's test that theory. All right, here's our octagon. Hey, what does it look like? Stop sign. Okay, so according to the pattern that we saw over here, we take the number of sides, we subtract it by 2, and that should give us the number of triangles. And each triangle is 180 degrees, so we just multiply that number by 180 and we'll find out how many degrees are in an octagon. Okay, let's go back to that page. So here is our octagon. It has 8 sides, so 8 minus 2 gives us 6. That means there's going to be 6 triangles. Each triangle is 180 degrees, so let's multiply it by 180. Get out your calculators. Plug it in. 6 times 180, and we get 1080 degrees. We can prove it by making our actual triangles. So I start anywhere. I could start here, doesn't matter. I'm going to start up here. So I'm going to go from this vertex to that vertex. Always start at the same vertex and go to every one that you can that's going to make a triangle. Let's count them. 1, 2, 3, 4, 5, 6. And each one of those is 180 degrees. 180 plus 180 plus 180 plus 180 plus 180 plus 180, or 6 times 180. So an octagon has 1080 degrees. And no matter what the shape, as long as it has 8 sides, it's going to have 1080 degrees. You know, let's go back to our heptagon because I don't think we did that one. Okay, yep, I'm correct. We left that blank. So we can apply the knowledge of taking the number of sides, subtracting it by 2, then multiplying it by 180 instead of counting triangles. So a heptagon has 7 sides. 7 minus 2, it should make 5 triangles. We take those triangles, we multiply it by 180, and do that on your calculator, and tell me how many degrees are there in a heptagon. Did you get 900? Awesome. Well, let's test it out. Let's see if a heptagon actually does have 5 triangles. Here is our heptagon. How about if I start right here? Go from that vertex to that vertex, that vertex to that vertex. 1, 2, 3, 4, 5. What do you know? Okay, so there are 2 ways to find how many degrees are in polygons. Alright, there are 2 ways to find the sum of the interior angles. That's the formal way to say it. Basically, how many degrees all of the angles add up to. The sum, which is addition, of the interior angles, the angles that are on the inside of the polygon. One way is to, you want to divide the polygon into triangles. Okay, and that can get kind of tricky, but you look at this and you go, from here to here, let's see, if I closed this up, then I could go from, what do I do? That could be kind of hard. So sometimes when you have irregular shaped polygons, this might be difficult to divide the polygon into triangles. Okay, and then multiply that number by 180 degrees. So I'm not quite sure, do I go like that? That's not really a triangle. This can get confusing. Uh-oh, I erased my whole bizarre shape. Let's go back to that. Okay, I just want to erase these red lines. There we go. Okay, so that's one way. If you have regular sized looking polygons like this, or like these, dividing them up into triangles can work. Sometimes, though, you'll get irregular shapes like these, which can be a little more difficult. Then I would suggest you use the second way, which is to count the sides, then you subtract by 2, and then multiply by 180 degrees. And there is a formula for that. And it looks like this. We're going to make n stand for the number of sides. So you're going to have the number of sides, n minus 2. You do that first, and then you multiply by 180. Alright, so let's count this up. 1, 2, 3, 4, 5, 6, 7. Well, that's a heptagon. So I've got 7 sides minus 2. That gives me 5 times 180. Well, it's going to give me the same answer as I did before. Are you starting to see that maybe all heptagons then will have 900 degrees? anything that has 4 sides is going to have 360 degrees. Let's go back and look at that other strange shape. This has 1, 2, 3, 4, 5, 6, 7. How much did this have? 1, 2, 3, 4, 5, 6, 7. Oops, I'm sorry. I forgot that one. That's 8. This is an octagon. I bet you guys saw that before I did. 1, 2, 3, 4, 5, 6, 7, 8. Yikes. Bad mistake. Alright, so this sure doesn't look like a stop sign, does it? But we do the same thing. 8 minus 2 equals 6 times 180. And 6 times 180 gives me 1080. That looks like the same amount it was for my polygon that looked like a stop sign. And it's going to be the same because they have the same number of sides. This next one was my heptagon. Come on, let's change pages so we can get there and show everybody. This was my heptagon. 1, 2, 3, 4, 5, 6, 7. 7 minus 2 equals 5 times 180. It's going to give me the same amount as any other figure with 7 sides. I believe that was 900 degrees. Alright, you try that one. Count up the sides, subtract by 2, multiply by 180. Has 5 sides. 5 minus 2 is 3. 3 times 180, did you get 540 degrees? Let's go back and check our chart to see if that's what we got before. Yep, all pentagons. And any pentagon, a polygon with 5 sides, is going to have 540 degrees. So that's kind of the cool thing. If you can memorize those, you don't ever have to do the work. But if memorizing them is not high on your priority list, then you can just remember the formula. And if you're getting onto a test, oh my gosh, I can't remember that formula, then you just change your polygons into triangles. Remember, start with one vertex and make your diagonals to each other vertex. Okay? Alright, we will practice more of this tomorrow. See you then.